Here is our last lesson for Chapter 2 in Geometry. So Lesson 2.8. We're going to be talking about vertical angles today. So these might be things that have popped up in a problem here or there that you just are dying to use. And after today's lesson, you can definitely use that again. But before we get to those vertical angles, we're going to talk about these things called opposite rays. And that's actually going to be our warm-up for today. So this might be vocabulary that we haven't actually talked about before, but hopefully using your logic and your process of thinking through some things, you could do these. Now, if you haven't done the warm-up yet, you probably want to pause your video and take a shot at them. All right, so warm-up number 1 says, draw two rays that are opposite that have the same endpoint. All right, so I have to have the same endpoint, right? So here's my endpoint, and I need rays that are opposite. So I could have one ray going in this direction. Now, the next ray has to be opposite, right? So you might say, okay, well, these two rays have the same endpoint. But if you look at those, would you say that those are opposite? I wouldn't. I would say they're going in different directions, but I wouldn't necessarily say they're opposite. So if the blue ray is going to the right, the green ray needs to be going to the left. This is what we call opposite rays. So opposite rays are two rays that have the same endpoint that go in opposite directions. Two rays with the same endpoint going in opposite directions. All right, so that is a picture of opposite rays. Probably should have written that. Okay. So problem number 2 says, draw two pairs of opposite rays that all have the same endpoint. So again, here's going to be my endpoint, and this time I need two pairs of opposite rays. So I could have, blue and green like this. There's a pair of opposite rays. Doesn't have to go left and right. Could go any direction you want as long as the two are going in opposite directions. And then maybe I have one going, I don't know. Let's see, maybe this direction. And then the second one would be going opposite, would be like this, right? So there are two pairs of opposite rays. So one pair is blue and green, the other pair is purple and orange. Those are two pairs of opposite rays that all have the same endpoint. All right, so that's an interesting picture, and hopefully you have something like that. Now your rays could go in any direction you want as long as you have two pairs that are opposites. But when you get a picture like this, we've created some angles, right? Here's angle 1, 2, 3. I see 4 angles other than the straight angles going on in that picture. And hopefully there's some things that are coming up in your brain of like, oh, I know some things about those angles, right? So first of all, like angle 1 and angle 2 are next to each other. You might say they're supplementary. We could also call them adjacent angles, right? Angles that are next to each other. But some more interesting angles that are hopefully jumping out at you would be, for example, angles 1 and angle 3, right? So those are what we call vertical angles. Vertical angles would be like angle 1 and angle 3. And hopefully you are remembering from your other classes that angle 1 is congruent to angle 3. Now, I'm not sure if you remember why. I believe in one of our other lessons we actually did this proof, but if you don't remember why, or if you don't know why, let's talk through it here. Here's my straight angle, right? We could say that angle 1 is supplementary to angle 2. Angle 1 supplementary to angle 2. You can see that they form that yellow straight angle, right? Well, here I have this second straight angle right here, my other pair of opposite rays. And if that's the straight angle, you could say that angle 3 is supplementary to angle 2. And if two angles are supplementary to the same angle, then they are congruent. And that's why angle 1 is congruent to angle 3. So because they're both supplementary to angle 2, and that's a theorem we did back in 2.4. So now we can prove, using our theorems that we know, we can prove why vertical angles are congruent, which I bet you never did before, right? That's one of the cool things, is it's something that you've just known forever, right? It's something your teacher said, yeah, vertical angles are congruent, and you never questioned it before, but after this class, you're gonna question everything, and hopefully you'll be able to answer just about everything. So vertical angles like angle 1 and angle 3 are congruent. You do have another pair of vertical angles as well, though. Angle 2 and angle 4 are also vertical angles, and those would also be congruent. All right, so walking through that process of drawing these things and then looking at them a little bit more carefully, you have actually proven our first theorem for today, which is about vertical angles. So our theorem is, if two angles are vertical angles, then they are congruent. Now, if you think about that, our if, part of this if then, is if two angles are vertical angles. So you have to have this step that says that these angles are vertical angles, okay? Now, if you look at this picture that we just drew, we saw that. We looked at it and said, oh yeah, angle 1 and angle 3 are vertical angles. So whenever you see that picture, because those vertical angles are based on straight lines, which are things that you can assume from a diagram, you can also assume vertical angles from a diagram. But you need to have a step in your proof that says angle 1 and angle 3 are vertical angles, reason assumed from diagram, before you can say that those two angles are congruent, angle 1 congruent to angle 3 with this theorem. Okay, so be careful. This vertical angles idea comes with two steps, an assumed from diagram step and then the congruent step. But hopefully it's something that comes pretty naturally to you. So here's a proof for you to do. See if you know how to use that new theorem in a proof. You're given that angle 2 is congruent to angle 3. You prove to me why angle 1 is congruent to angle 3. Go ahead and pause your video, and then when you're ready, you can check it using the link down at the bottom, or you can watch and I'll walk you through it. Okay, so first step here, angle 2 is congruent to angle 3, and the reason is given. Angle 2 congruent to angle 3. I'm trying to prove that angle 1 is congruent to 3. That's what I'm trying to get to. Again, I highlighted it so I could see what I'm trying to get to, but I don't know that yet. Well, I know 2 is congruent to 3. Angle 1 and angle 2 hopefully is jumping out at you. Hey, those are vertical angles. So again, like we just said, I need to first have a step saying angle 1 and angle 2 are vertical, squeeze it in there, angles, assumed from diagram. So I have to have that assumed from diagram step. I can't jump straight into that they're congruent, because then my if would be left hanging. If two angles are vertical angles, what? They are? That's not in your proof. So make sure you have that assumed from diagram step in there. And then step 3 is that angle 1 is congruent to angle 2. If two angles are vertical angles, then they are congruent. So now I know that angle 1 is congruent to angle 2. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. Congruent, proving angle 1 is congruent to angle 3. I probably said that wrong. Let's see. Angle 1 is congruent to angle 2. Angle 2 is congruent to angle 3. I'm trying to prove angle 1 is congruent to angle 3. Congruent. That sounds a lot like the transitive property. Step 4, angle 1 congruent to angle 3. If two angles are congruent to, are they congruent to two congruent angles or congruent to the same angle? 2 is congruent to 3, 1 is congruent to 2. Maybe if I rephrase that a little bit, 3 is congruent to 2, 1 is congruent to 2. They are both congruent to the same angle. There's only 3 angles up there in that picture that I'm talking about. So if 2 angles are congruent to the same angle, then they are congruent. So that was our transitive property that we used there after we had our vertical angles. So hopefully that helped you link up that lesson from yesterday. Again, still remembering how to tell the difference between substitution property and transitive property, but also using that new vertical angles theorem. I think that one will stick with you pretty good. Just don't forget your assume from diagram step. And hopefully as you're writing that if-then form, that'll help you catch it. Oh, if 2 angles are vertical, oops, forgot to write that they're vertical angles. Sneak that step back in there. All right. So this one's a pretty easy one to use in proof. So the next problem actually is how might you use this not in a proof, maybe in an algebra type problem. So you're given that angle 4 equals 2x plus 4. You're given that angle 5 is x plus 30. Find the measure of angle 4. I bet you guys know how to do this. Don't forget, in any problem like this, when it's not a proof, it's a find, it's not a prove, so you don't have to write a 2-column proof, but you have to show your work. That's your proof of your answer, is your work. So go ahead and write an equation, show your work, see what you get. All right, since it's not a proof, I don't actually have to write a step or anything like that saying that angle 4 is congruent to angle 5. I see their vertical angles, I know they're congruent, so I can just jump right into saying 2x plus 5, oops, I wrote that wrong, 2x plus 5 equals x plus 30. All right. So let's go ahead and solve that now. I'm going to subtract x from both sides. I get x plus 5 equals 30. I'm going to subtract 5. I get x equals 25. All right. Now, am I finished when I say x equals 25? No, I am not finished when I say that because it asked me to find the measure of angle 4. So angle 4 is 2 times 25 plus 5. So angle 4 is 50 plus 5. So angle 4 equals 55 degrees. And you could always just double check and plug into your other one and make sure that would make sense. If I just to double check and I said, well, what is 25 plus 30? That does equal 55. They are equal to each other because they're congruent, so I didn't goof anything up. So angle 4 equals 55 degrees. That's how you'd use that in a algebra type setting, one where you don't have to prove it, just use it. All right, hopefully you're super confident. That's a nice one to kind of wrap up our chapter 2 with when we have all those theorems and properties buzzing around in our heads, a nice straightforward one to finish it up. So just be able to recognize opposite rays, and you know the reason you have to recognize opposite rays is to really pick out those vertical angles from a picture. Remember, vertical angles are congruent, but don't forget the step in your proof that says you have vertical angles that assumed from diagram step before you jump straight to your congruent theorem. The book does not always do a good job of that. Sometimes the answer key skips that assumed from diagram step, but you have to have it, so don't forget. All right, just a couple of problems to make sure you're super solid on that vertical angles theorem. If you do have any issues with it at all, though, go ahead and do some additional practice problems and ask your teacher some questions.